welcome Joe Inertia.
Joe will be teaching us how we can increase performance and lower costs when deploying large parameter models. So large language models, generative AI, they're really hot topics right now. Can you elaborate a bit on them?
Sure, yeah. I think it helps if we maybe take a step back and talk about, what is generative AI and what is the movement we're seeing here. And really, it's about generating content. It could be generating images, generating video, generating text. And, within that, large language models is just one subset of that generative content that we've seen. And, really why it's become so popular is there's been recent breakthroughs that have made, when you're interacting with an image that was generated from, one of these AI models or, potentially language that's generated from a chatbot from one of these, it's hard to differentiate between, a human and a computer. And, that has made the experience really, valuable for end consumers of the products. And behind that, behind the scenes, what kind of the data scientists have done and the breakthroughs that have enabled this is kind of the scale at which these models have grown. And so we see an open source model that's pretty popular. It's a generative pre-trained transformer by Hugging Face. It's called Bloom. As an example, this is 176 billion parameters. So when we think about that, 176 billion parameters, each one of those parameters is stored in 2 bytes. And that means that you have about 352 gigabytes just for a single model to process. And all of those bytes have to be used for the computation as you're inputting messages to that model.
So what are some of the challenges that customers face when deploying these very large generative AI models?
Yeah, it's a great question. So a lot of what we see is, again, I mentioned 176 billion parameter models. There's even larger models, and when you think about that, it requires a lot of compute to process a single input going through that entire deep neural network of 352 gigabytes of data, and that's all mathematical computations that your server has to do. And so what happens is you end up having to require a pretty significant amount of compute, which drives up your costs, and it also drives up the energy that you're using. And so, the options that kind of, what we see our customers choose off are, okay, do I, choose, maybe a larger machine learning training instance that's, has really heavy compute power, but isn't really cost optimized for inference, or do I go with, an existing inference optimized option that's maybe not necessarily optimized for the performance you need for these large models?
And so this is all very new, exciting technology, but it sounds like AWS has seen this trend developing and is already prepared to support the future deep learning trends with the newest machine learning silicon, AWS Inference 2. Can you tell us a bit about Inference 2?
Yeah, and I think it's important to start, before jumping into the accelerator, which is Inference 2, but look at kind of the innovation and infrastructure that AWS has had. We had our hypervisor, Graviton instances, and also other machine learning silicon instances. And for our machine learning silicon, that really started back in 2019 when we announced Inference 1. And the Inf1 instances, when they came out, talking to our customers, they delivered up to 2.3x higher throughput, and some customers were saving up to 70% over comparable GPU-based instances. And we had a lot of customers that were really enjoying the benefits. We had customers like Airbnb or Snap, or even ByteDance recently published a blog about running on Inf1. But the nice part is we're working with these customers and we're so engaged with them, we're learning, and one of the feedbacks is, hey, research is leading to bigger, larger models. So then last year we announced, kind of based on that feedback, Tier N1 instances, which were built for these large scale-out training of these large language models. And those we're seeing customers save up to 50% cost savings running training on those instances. So, going from there, then to say, okay, we know they're training these large language models, how are they going to deploy them? That's where Inference 2 comes in. And so we really have the opportunity now where Inference 2, we built this accelerator, and optimize the compute and the server resources around it to make an instance that is going to be capable of running, both high performance and also cost efficient for these large generative AI models.
So can you talk a little bit more about the Inf2 instances? What does it make it more suitable for these large, ultra-large language models?
Yeah, so I think there's 2 elements here, and we talk a little bit when we think about an actual Inf2 instance. It's a full server, and within that server there are 12 Inference 2. So Inference 2 is the actual accelerator. So we innovated both at the accelerator level and also the server level. And so, compared to our Inf1 instances on, a single accelerator on Inference 2, it's actually 3 times higher compute. So we talked about how important compute is. We added a lot more of it because we knew we were going to be processing more numbers for these large models. And then we also added more memory, 4 times higher memory. So we went from 8 gigabytes of DDR4 to 32 gigabytes of high bandwidth memory. And the reason we went to high bandwidth memory is we also have now 10x higher memory bandwidth, which is really critical as you're passing parameters back and forth to multiply and compute on. And then when you take a step back and you look at the actual server, so again, I'm going to come back to that 352 gigabyte parameter model. So I only have 32 gigabytes on a single accelerator. So obviously, I can't fit the entire model onto a single accelerator. I need to shard that model across multiple accelerators. So what we did was, knowing that that's going to be something that our customers are looking for in the future, we added a neuron link, a connection, a high-speed, ultra-high-speed connectivity between the accelerators, so that those accelerators can directly do the communication and shard the model, so that they can run, and deliver both the throughput and the latency that our customers expect for these large models.
And so I know these are good for generative AI, but what type of applications are suitable to run on Inf2 instances?
Yeah, so similar to our Inf1 instances, we see all of our performant on all of the natural language and computer vision models that we had running on Inf1. But with Inf2, we really expanded the field here. So again, talking about what we see in terms of kind of large language models and generative AI, we have things like generative pre-trained transformers, vision transformers, diffusion models, recommender models that require kind of that more memory and that neuron link to really be performant. And then what that enables us to do is, okay, those are model architectures. What are the end applications customers are actually looking at now? So now we have things like text summarization, question answering, image generation, kind of those broader applications that our customers are exploring because they have access to those more model architectures. And one of the nice parts is, because we're continuing to optimize that software stack, we'll have performant models at day one. Like I said, some of those GPT models or BERT models, and then as we scale out, you'll see more performance and also optimization for more models in the future.
And models like Hugging Face Bloom or Meta's OPT that power these generative AI applications are very popular. So how is Inf2 helping address the price performance and the sustainability challenge that come for those?
Yeah, so it's a great question. I think when we look at kind of the benchmarks, so start there, just because that's what we kind of how we measure both the throughput and also kind of cost efficiency, but also power efficiency. And for an OPT 30 billion parameter model, we see up to 3x higher performance on our Inf2 instances compared to the inference optimized GPU instances. So right out of the box, when you have a similar power footprint and higher throughput, you're getting both cost efficiency but also power efficiency right there. And then it's only exemplified when we go further. When we have an OPT 66 billion parameter model, what that means is then your GPU instances that were optimized for inference, they actually start to run out of memory, whereas Inf2 still shines. And we're delivering 300 tokens per second on large input and output sequences for some of these really large language models. And so it all comes together to really build this this server that's thoughtfully built so that we're optimizing for both cost, performance, and energy efficiency.
And so do developers need to make any changes to their applications to run on Inf2?
No, the nice part is, so we, starting with Inf1, we thought about the software stack and we had been designing for ease of use. And so what that means is at the software level, we have an AWS Neuron. It's a software development kit, SDK. And so the software development kit is actually built with a compiler, profile, runtime tools. And the compiler allows us to take basically the models that you're running off the shelf and optimize them to run on the hardware. So there's the element that we're taking the math out of you having to understand that basically how compilers work and help you optimize performance automatically. And then there's also the part where we've actually integrated AWS Neuron SDK natively with PyTorch and TensorFlow. So our developers just operate at that application framework level and they can deploy their code pretty easily.
So how would you recommend that our developers get started on this?
Yeah, so we're still in preview for Inf2, so I definitely recommend checking out the Inf2 product display page. So if you're interested in signing up, that's the best way to get a hold of us. And getting started is pretty easy. There's in general, we have access to all of the AWS services that surround a standard EC2 instance. So customers who are using Amazon S3 for their model artifacts, or if they're using FSS for Luxter, if they need that type of capability, all of that which comes right out of the box with Inf2 instances. And then for customers who want to deploy right away, they can use a deep learning AMI or a deep learning container for containerized applications, and we have all of them packaged with the frameworks that they need to get started. We're working. Once we get to GA, we'll have support as well for our ECS and EKS. So it's Kubernetes and containers, basically for managed orchestration of your actual containerized applications. Or the last option, if you really want a fully managed experience, when we come to GA, we'll have support for our SageMaker inference endpoints, so customers can deploy and have the benefits of the fully managed package of SageMaker.
Awesome. Well, thanks so much for joining us today, Joe.